Okay, I'm going to talk more in more detail. Let's see if you can see this. All right, notice here I've got the full Monty here. Amplitude times my sine or cosine. Here's your B, which affects you the period of your graph. X plus or minus C. Here's a phase shift and then a vertical shift outside the parentheses. Here's what we're going to work. A -3 sine of 3/4 x plus pi over 3 plus 1. Okay? The biggest thing we want to do first is let's always focus on the period. This is my B. Okay? Remember that the period equals 2 pi divided by B. 2 pi divided by 3/4, okay? Remember, the 4 is going to come up in the numerator. It's going to be 8/3. And if you remember your fractions, remember 2 over 1 is basically 2. And I'm going to multiply by the reciprocal of 3/4. 4 over 3 equals 8 over 3. And that's in pi, remember? Okay, don't forget the pi. So 2 divided by 3/4 is 8/3 pi. All right, so instead of taking 2 pi to do a complete sine graph, we're going to have to go an extra 2/3 pi. Okay? Remember, 3 goes into 8 2 times with a remainder of 2/3. So on our unit circle, we normally go through a full graph in 2 pi. But we're going to have to take another 120 degrees to complete this graph, another 2/3 pi. All right, I always like graphing the original, and we're doing sine, so let's graph our original values. We know sine is what? 0 at 0 and 2 pi. So here, all right, I forgot where I was. My kids interrupted me. I had to pause it. Okay, sorry. Let's get this focused. Okay, so the sine graph, remember, sine is 0 where? At 0 and at pi, and it's 1 and -1 at pi halves and 3 pi halves. Okay, so now you can see it's 1 at pi halves and -1 here, and, sorry. Okay, so sine 0 at pi halves we're 1, at pi we're back to 0, at 3 pi halves, we're all the way down here at -1. Okay? And then we come around to 2 pi. We're back up here. Okay, so here's my original graph. Make these important points knowing 0, pi halves 1, pi 0, 3 pi halves -1, back up, okay? All right? So my graph would look something like this for sine, and you should know that cold. All right, now let's affect our new period. We're going to take all the way to what? 8/3 pi. So let's count our 8/3. We know that's 2 pi plus another 120 degrees. So here's my 2 pi. But let's, every third pi, 1/3 of 180 is 60 degrees. Okay, so notice what I made my hash marks, my dashes, 30, 60, 90, 30, 60, 90. So every 2 of these is 60, or pi thirds. 1 pi third, 2, 3, 4, 5, 6, 7, 8. Okay, right here. So let's make a new graph. Here's what I call my bookends. Okay, all right. So now my graph is going to, the sine graph is going to take this much space to complete the graph. All right. Now notice the original graph, the 0 is right in the middle. Well, now my new graph, the 0 needs to be in the middle of it too. I'm going to count my hash marks, 30, 60, 90. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 16, so half would be at 8, 4, 5, 6, 7, 8. So here's my new middle, 1, 2, 3, 4, 5, 6, 7, 8. There's my new middle point. So now my 0, instead of being here in purple, it's there. Okay? Now remember, the 1 was in the middle of the original first half of this graph had the 1. Well, now what's the middle of this new first half? Well, that's 8, right? So it'll be at 4. Okay? Here's my new negative. The negative one was in the middle of the second half in purple. Well, now in blue, here's my second half here. Remember, it's 8, so half of 8 is 4. 1, 2, 3, 4. Okay? So now this point here is right here. Okay, so here's my new graph with just, okay, the effects of just the period. Okay, so right now we've taken care of the period. Now, always do the period first. Another way to do it would just be go through and put all your values of 3/4 and plug in values of pi 6, pi 6, pi thirds, pi half, going all the way around the unit circle until you graph out a full 2 pi. But this is an easier way, I think, of doing it. Instead of just plugging in values until you get all the way around, until you get a full 2 pi. And it would take you 8/3 to plug in before you got 2 pi. Okay? Alright, so I like doing it this way, kind of with ratios. Alright, let's do our amplitude next. We could do the phase shift. I could shift this either shift and then do the amplitude, but I'm going to do the amplitude now. And I'll use this green. The amplitude is going to be the absolute value of this -3 here. There's my amplitude right there. Okay? It's going to be the absolute value of that. But I'm going to multiply every value here in blue now by -3. Remember, anything on 0 doesn't move. Okay? Alright, so here's 0. 1 times -3 is going to be -3, so we're going to shift all the way down to here. Back to 0. This one here is -1 times -3 is going to be +3. 1, 2, 3. And this one stays the same. So here's my new graph. Okay? We got 2 more things to do. I've affected these 2 things. Now let's do my phase shift. Plus pi thirds, that's plus 60 degrees. That means left 60. So all these dots, let me put them in pink now. I'll move all my little points to the left 2 dashes. Okay? So this one's going to go here, 60 degrees, 60 degrees, 60 degrees, 60 degrees, and 60 degrees. Okay? And before I even combine those, I've got one. So now I've done the phase shift, and now I can do the vertical shift, plus, and this is, plus does mean up. Okay? And let's make that, shoot, I had another marker. Here it is. Let's do this one in green. Okay? Alright, so now from this last pink, let's move up 1. Okay, so I'm going to move up 1 here, here. Okay, up 1 here. I'm moving the pink. Up 1 here, and up 1 here. And that's our final graph. We go. Okay, it's important to know what's my amplitude here. 1, 2, 3, 4. My min is 4 minus -2 divided by 2. That gives me an amplitude of 3. Notice it's an absolute value. It's important to know where this because if my amplitude's 3, I know if it's the difference from top to bottom is actually 4 minus -2 is 6 over. This right here is 6, and 6 over 2 is 3. Okay? But I know if I'm going from a graph and I need to get an equation from my graph, it's going to be important to know where the middle of the graph is. Okay? When I know where the middle of the graph is, I can start moving this middle point. I can shift it left and right to get it back where it needs to be to see whether it's a sine graph or cosine. Okay? All right. final thing, I think I mentioned, I can't remember if I mentioned this in the last video or not, like I said. Here's a sine graph, and here's a cosine graph. Okay? You can make these graphs cosine of x minus pi halves. If this moves over the right to pi halves is going to equal a sine graph. Okay? If these points are going to move over pi halves. I think I drew that wrong. Okay? Anyway, in the sine graph, we'll look at this later, x plus pi halves equals a cosine graph. Okay, so if you look at this, let me make it a little better. Pi, 2 pi. Here's cosine. Okay, and here's sine in green. Notice if this point moves over, if my cosine graph shifts right, pi halves, all these points match up. The blue matches the green. Notice the green, if I shift my sine graph to the left pi halves, notice how these points match up. Okay? So cosine shifted equals a sine, pi halves, and sine shifted to the left equals a cosine. Okay? Alright, that's all I have. It's 2 videos you need to watch today. Thanks.